So, Dr. Jonny Bowden, thanks so much for joining me today.
Oh, it's my
I'm
pleasure.
going to it's and I first learnt about you when I saw a fantastic documentary on called The Heart of the Matter. It was
Oh,
it's quite an old one. It's in a it's a for those in Australia know 60 minutes. 60 minutes is a current affairs show, and it was a very good documentary, literally on the heart of the matter of cholesterol, and that that cholesterol is bad. That blank statement or that saturated fat is bad for heart health is probably the biggest myth in medical history, and I always thought I would do a podcast on it just to get the message out there and just, the intention of this podcast is really uh, to send to my patients, to set for you listening, for yourself, if you kind of might think that eating fats or eating saturated fats is, not good for diet or bad, or maybe your doctor told you that or your health practitioner. So it's for doctors, it's for you to send to a family member, a friend who is doubting that and kind of ingrained in that thought. Um, but also, I will link that documentary in the show notes because it was really, really fantastic. And instead of making a podcast all these years, I just was directing people to that documentary because it was so good. It's featuring many doctors and practitioners, one of them being Jonny Bowden. But before we go into anything, Jonny, I like
yeah,
to start my podcast with asking you,
yeah.
what did you do this morning? What was your morning routine?
2 hours on the tennis court in my weekly four-person doubles lesson that we have every Tuesday from 8 to 10 in the morning, and that's what
Beautiful.
I started my day with.
And any other morning routine before then, before that 8 a.m.?
I have a set little routine I go through every morning from making that starts with making the bed, drinking 8 ounces of water, feeding the dogs, feeding the fish, meditating, shaving. So I have my own little like morning ritual that I do every single morning, and I believe very strongly in rituals. I think they're very stabilizing. I think they're mentally grounding, and I think they set the tone for the day.
Beautiful, yes, and that's why we asked because in Ayurveda it is very important, to have the routine and the regularity. So we are going to talk all about cholesterol. As I said, the intention for this podcast is to get things straight. We kind of did a similar episode with fluoride. It was called Fluoride: The Definitive Truth and Your Water Supply. That was episode 15 with Marilyn Hayes. It's just to kind of just get it straight out there because, you know, despite the science, this dogma that cholesterol is bad for health or that saturated fat is bad for health, particularly heart disease, remains pervasive,
Yeah.
despite science showing that natural fats pose no increased risk of heart disease.
Right.
Hospitals, are still giving this information. Can you believe this, Johnny? You're very well versed in this. You wrote a book, um, "The Great Cholesterol Myth," and can you believe that doctors are still ingrained in this dogma?
Well, I can very much believe it because the history of science and of nutrition is littered with stories of something being discovered and it taking approximately 50 years, 25 to 50 years, for there to be some level of establishment acceptance of that. And I can go back to 1730 when an English sea captain discovered vitamin C and discovered that it basically cures scurvy. And it took him about 50 years for that to be an accepted
Mm.
compound. Um, I don't know if you know that story. It's kind of really interesting. But basically, vitamin C was discovered by accident. They used to do these, use exploration discovery ship things from every country in the world. Spain, sent out the Nina, the Santa Maria, and the Pinta. So these sailors used to die, and they used to die in droves. They'd come back with half of their crew. Half of the crew was corpses, and they didn't know why. And this particular captain he was an English sea captain, and for whatever reason, personal taste, who knows, he used to have lots of limes and lemons on board. And his sailors didn't die that much, like a fraction of them. And this is how the English sailors became known as limeys. And it was finally discovered that the substance in the limes or in the lemons, ascorbic acid, actually prevented this disease, which was now identified as scurvy. It took about 50 years before vitamin C was an accepted vitamin understood to be essential, understood and recognized where the sources of it in the diet, but it takes a long time for people to change their ways. And this is true whether it was the discovery of homocysteine, a high inflammatory marker in the blood. Got about 25 years that got ridiculed before it was finally accepted as a risk marker for stroke. And in the same way, we discovered the history of cholesterol and cholesterol measurement and cholesterol research, goes back quite a ways. And in the big, let's just call it the 60s, kind of the place where cholesterol became a term that like regular people heard of. I mean, there were experiments on cholesterol going back to 1913 with rabbits, but before the general public ever heard the term cholesterol, it wasn't until uh, maybe the 1960s, we had a president in the United States called Eisenhower, and he had suffered a heart attack in office, and people were very, very distressed about that. The heart disease was not well known; it wasn't an epidemic at the time, but all of a sudden it was on everyone's radar, and there were theories abounding. How did this wonderful, fit, terrific, beloved guy, have a heart attack? Could that happen to us? And there were theories, and one of the theories that was vocally and voraciously promoted was that it had to be related to fat and cholesterol. This guy came up with a theory: cholesterol in the blood and fat raises it, and he was quite sure of that. And they did a bunch of observational studies that seemed to show, they actually didn't show this, but they seemed to show at the time that the countries where they ate the least amount of fat had the least amount of heart disease, and the countries where they ate the most amount of fat had the most amount of heart disease. And this theory was quite convinced that the reason for that was that fat just raised cholesterol and we needed to stop eating fat. And that kind of informed the dietary guidelines in America from the 80s on, and those guidelines were more or less adopted by every major westernized nation in the world. So everybody basically recommended low-fat diets for the prevention of heart disease. There's a couple of problems with that have come out since the 1960s. For
Mm.
one thing,
Yeah, yeah.
when
And before we get into that,
saturated,
like
what?
before we go into that, the actual science that was being, it's based on flawed science. I mean, the science that was coming out was linking saturated fats, you know, to increase cholesterol, but very few of them, if any, were linking it to directly to heart disease.
Well,
And
that's an interesting point you bring up, Dylan, because that's exactly what the research, starting about 10 or 15 years ago, started to show. They said, well, all right, we got all these studies showing that saturated fat raises cholesterol. And we're going to put that aside for a minute, what that really means when they say it raises cholesterol. But let's say,
because cholesterol doesn't necessarily mean bad.
well, we're going to get into that. But
Yes,
let's
we
just
will.
use the old fashioned way of talking about cholesterol. LDL is bad and HDL is good. And they had all these observational studies that showed that eating high fat diets was linked to high cholesterol. And we all know high cholesterol is linked to heart disease. But around 2010, they started doing some studies where they looked not at the intermediary risk factor, the lab test cholesterol. They said, we want to know whether people who eat more saturated fat actually die. Because let's face it, who cares what your blood cholesterol is? We want to know. It's only important. We only look at those kind of markers because we don't know if they tell us something about the future. We want to know if we're at risk for something. So they're really just surrogate markers to kind of give you a hint of what's coming. So what these folks wanted to know was, let's skip the marker and let's just see if people who eat more saturated fat actually have more heart disease. And that's when those studies started coming out. And guess what they said? No, they don't. When you take cholesterol out of the picture and you just look at fat intake versus dying, or fat intake versus heart disease, or dying from heart disease, the relationship dies. There isn't really very much of a relationship there. Now, those studies, which we list all of them in the Great Cholesterol Myth in the revised edition of that, have shown pretty much that the connection between eating saturated fat and dying is a kind of construct that just isn't borne out by the research. Now it gets even more complicated, and this is why it's so hard to explain to lay audiences. Because the very thing that we are measuring, the cholesterol, that everybody is afraid of having high cholesterol, we are measuring using an outdated, obsolete, inaccurate test. So this whole edifice of saturated fat raises cholesterol and cholesterol raises heart disease has so many holes in it. The first of which is the measurement for cholesterol is out of date. So whatever you got on your cholesterol test, high or low, it doesn't matter. And here's why. In the 1960s, they only measured total cholesterol. They would do a fingerprint and they'd go, oh, Mrs. Jones, your cholesterol is 230 or it's 210 or it's 190 or it's good, it's medium, it's high, it's whatever. And you'd have some information about your blood cholesterol. Well, around the 60s, it became easier to measure cholesterol, and they actually noticed, cholesterol doesn't even really travel in the blood. It travels in containers called lipoproteins. And we think there's like two different kinds of them. There seems to be one that's kind of high density, and there's one that's kind of low density. And by that, I mean that a high density one would be very heavy. So if you put it in a waterous solution, it would float to the bottom. It would go right to the sink to the bottom. But a low density one is kind of light, so it will float at the top. So these two containers look a little different. Let's call one of them HDL for high density lipoprotein, and the other one let's call low density lipoprotein for low density LDL for low density lipoprotein. These lipoproteins were the containers which held cholesterol. Okay, that was 1963. We now know that there are 13 different subtypes of cholesterol. That lipoproteins are really what's important, not the cholesterol. Lipoprotein is the boat. Cholesterol is the cargo. You want to prevent an accident in the water. You want to know how many boats are in the water. You don't care what they're carrying. You want to know how big they are. And you want to know how many there are. Because that's how you manage accidents. The more boats in the water, the more likelihood one is going to bump up against the other. There's going to be an accident. And when you're talking about the bloodstream, the exact same thing is true. So for 40, 50, 60 years, we have been concentrating on measuring the cargo of the boats instead of the number of the boats in the water and the size of the boats and how they behave in the water. We now have technology to measure all that. That HDL LDL test is as obsolete as a flip phone. We can go in there now and measure all 13 different subtypes of cholesterol. We can know how many LDLs there are in the bloodstream. That happens to be a very important number. How much cholesterol there is isn't, but number of boats is. We can measure the shape of them, whether they're big, fluffy particles and lipoproteins are the same thing. So whether they're big, fluffy lipoproteins, which don't tend to do all that much damage, or they're really nasty little inflamed, atherogenic little BB gun pellet size particles, and those are damaging. But an LDL test doesn't tell you what kind of LDL you have. Just as the total cholesterol test was updated with the HDL LDL because we now knew that there were actually two ways the cholesterol traveled around. Why are we still using that one when we now know that there are 13 different ways cholesterol goes around in the body, and that the size matters, and that the number matters, and we have tests to get all that information, and we're still using this obsolete test? So look at the whole hypothesis and look at how it falls apart. Saturated fat may, in fact, raise LDL cholesterol, but who cares? Because we want to know what's under the hood with that LDL cholesterol. In fact, the one study that I know of where they actually substituted saturated fat for some of the other things in the diet that, were supposed to be healthier. And they said, wow, LDL really goes up. But wait, let's not stop there. Let's see what's under the hood. And they go, oh yeah, LDL went up. But because it was mostly the nice, fluffy, kind of benevolent LDL molecules, while as the ones that are really atherogenic went down. So you actually, even though your LDL went up, your lipid profile actually improved, because when you use this new technology to see what kind of LDL we're talking about, you find out that there's actually an improvement there that is masked by simply looking at the LDL number.
So, folks, you can now ignore the cholesterol numbers on your common blood test that you get. Common blood test will just have HDL, LDL, and total cholesterol. That's at
Yeah,
least what I see in Australia.
that's the old-fashioned. It is an old-fashioned test, and I would argue. I'm going to argue two things. Most people who are taking statin drugs were prescribed that drug based on that old test. I would never take a prescription based on that outdated test. I would ask for the more modern test. Now, I'm not saying that your doctor's wrong to give you a statin. I'm saying he's wrong to give you a statin based on that test. So
Mm,
understand that we're not saying cholesterol doesn't matter. We're saying the way we're measuring it doesn't matter. So we can
yeah.
pay no attention to that. But that doesn't mean don't measure it. It means measure it correctly. It's like
Mm,
saying just because I hate the flip phone doesn't mean I don't want to use a phone. I just want to use an iPhone 12 that can actually text and send pictures, not just one
mm.
that flips and I have to hit it 3 times to enter the letter A. So
So
that's
funny.
what we're using when we're using HDL, LDL.
Yeah. So if your doctor is prescribing you or telling you you have an issue with your cholesterol, which means you got to
But you may have.
stay off fats,
Yes,
which you
the
may
test
have.
tells you the truth about it. Now, I'm going to give you here, Dylan, look at this. This is the other side of that. Everybody always talks about how we overprescribe statins, which we do, based on this ridiculous test, which we do. But here's a case where a person could be undertreated by using the old test, where you could actually miss risk factors. And I am a perfect example of that case. So for years, my LDL HDL test was perfect. My LDL number was the kind that a regular doctor, a conservative doctor, a non functional medicine doctor, a basic conventionally trained doctor who doesn't look at nutrition and just sticks with the talking points that are right in there and been in there for the last 20 years, that doctor would be thrilled with my LDL numbers. When I learned this information over the last decade, I started having the correct cholesterol test, and the correct cholesterol test showed a very different picture. My LDL, measured in the old-fashioned way, was just fine, but I had a particle count and a lipoprotein count of something like 2,600. That's high risk. Those LDL particles were small, like BB gun pellets. That's high risk. Didn't matter that the total LDL was perfectly good. The type of LDL was the worst kind, and the number of LDL was very, very high. This is not shown in the classic test. So I'm a perfect example of somebody who needed to be treated, not necessarily with a statin, but needed to pay attention to those heart disease risk factors because they are concealed. In my test, in my class case, they were concealed by the old test. And in many cases, a good bill of health is concealed by the old test. And those are people who are walking around on statins that don't need to be on, because if you did the real test, they might find out that they're not at risk.
How many doctors are using these more progressive modern tests to test these extensive cholesterol size and these
It's
different
growing. It's
testing?
growing. When we first wrote The Great Cholesterol Myth back in 2010, uh, it was a uphill climb. You'd go to certain conferences like the American Academy of Anti-Aging Medicine, and you'd go to the nutritional conferences, and you see the same 300 doctors. Um, there's 800,000, 900,000 physicians in America. The same 300 doctors going to the nutrition conferences means a very, very few percentage of them are aware of this, but it has changed. There is a loud and vocal minority among medical doctors, especially in the functional medicine community and the naturopathic community and the you know in the community of MDs who also are trained in nutrition and functional medicine. There's an enormous a movement towards abandoning the old-fashioned test and using the modern tests for real risk factors in cholesterol and blood lipids, and also looking at some of the other risk factors that are even bigger than cholesterol. And I'd love to talk about that in a minute. So there
Mm.
is a change over to that. These newer tests used to be very difficult to find. You had to order them. Not all the hospitals or not all the doctors knew about them. Now you can get them from LabCorp and Quest, which are the two biggest commercial labs in America. So I'm assuming you can get them everywhere.
Yep.
They're much more common now. You still meet huge pockets of resistance. They're not always covered by insurance. Doctors don't always know about them. The ones who do the 7-minute appointments are not necessarily going to order these tests. They're going to go, hey, the old ways have worked for us for years. We're going to stick with those. So it's an uphill battle. but I think this landscape is changing. People are beginning to realize that cholesterol is not, certainly cholesterol as we currently measure it, should not be the target of heart disease prevention. And what I'd like to talk about is what should be the target of heart disease prevention. Because,
Okay, before we get into that, I just want to elaborate a bit more on the testing.
yeah,
So the power is in you, the patient. You know, if your doctor's telling you to say, "Well, can you get me a particle analysis and measure the size of my cholesterol particles?" And just to again, just repeat that it's the size. One aspect is that the size matters, and if you can have good LDL or bad LDL, and you can have good LDL and bad HDL, good and bad for both.
yeah.
So if it's big and fluffy, it's just gonna, it's like a nice cotton ball floating around in your blood. It's not gonna really hit anything. But if it's that small, dense, hard, it can penetrate the arterial wall and cause inflammation and damage.
And
So,
you want to see how complicated it gets and why it's so difficult for people like me to explain it to general. Yours is a sophisticated audience that knows about health. You imagine going on national television with a general audience who barely knows about what the difference between fat, protein, and carbohydrate is, and trying to explain these distinctions in measuring cholesterol. It's a very uphill battle. People are,
mm,
it's a hard message. I'll show you how difficult it gets. You just explained beautifully how some particles are large and fluffy and they're not so dangerous, and that's kind of what you want. You want those particles to be, and you don't want them to be small. Well, in HDL, it's the opposite. In HDL, the small particles are the good ones and the large ones are not so good. So it's a
mm,
complicated thing. And I think the thing you have to take away from this, if you're a general audience member, is good and bad cholesterol is obsolete. It's much more complicated than that. And we know how to measure it. And we know how to tell you whether you're really at risk or not. And it's no reason to stick to these old tests, they're irrelevant.
hmm okay. And as well as the size of cholesterol, what about oxidization? That's another
Well, this
factor,
is
right?
such an important point that you bring up. Thank you for asking that. See, cholesterol in the body is never a problem until it gets damaged. So those fluffy little molecules that are just those fluffy little particles just floating around there doing when they get damaged, when they get oxidized, when there's oxidative damage on that cholesterol, that starts to mount an inflammatory response. The immune system starts going after them like an injured, like a pack of lions goes after the injured one in a fleet of elk or caribou. Those oxidized particles of LDL, the immune system goes after them and they become inflamed and then they get small and irritable and angry, if you will. And that is the little particle that gets stuck, that gets into a parking spot it doesn't belong in the endothelium wall, which is the lining of the artery. Now you get one of those nasty little particles stuck in that parking spot that it doesn't belong in. Now the immune system mounts a full blown attack. Now you go into macrophages and foam cells and plaque development and all that stuff. But it doesn't happen until cholesterol is oxidized, until it's inflamed, and it doesn't get stuck in the wall till there's some damage in the wall to begin with. So we have to look at what causes that damage and what causes that oxidation. And in our book, we talk about inflammation and oxidation as the twin pillars of cellular destruction. Those two processes cause all of the damage to begin with. That's what damages cholesterol. That's what damages the endothelial wall, gets the particles caught in there, starts the whole process, the whole cascade of events that leads to plaque. So we really can't talk about heart disease without talking about inflammation and oxidative damage. Those are two important processes that really degenerate our cholesterol and cause it to be a problem in the first place.
Okay, we're gonna talk later about overall heart health, metabolic health, and the different causes of disease and how we can help and rectify that. But let's just take it a step back. And you just mentioned how cholesterol can become virulent and cause disease. But what about? Let's just take a step back and what is cholesterol and why is it essential for life?
Well, it's very essential for life. In fact, I used to do when I would do in the days when we could do things in person, I used to have a demonstration I would do in which I would blow up. I'd have a big balloon blown up, and I'd say, these are your cells on cholesterol, and then I'd put a safety pin into the balloon and prick it, and it would collapse like a dead cell, and I'd say, and that's your cell without cholesterol.
mm,
Your cholesterol is needed for the cell membrane, it's needed for immunity, it's needed for thinking and memory, brain health, all of that stuff. It doesn't exist. It's a prohormone. It's the parent molecule for vitamin D. Uh,
mm,
it's the parent molecule for sex hormones. I mean, it's no coincidence to me, to my way of thinking, that we have literally in my country an epidemic of erectile dysfunction among middle-aged men, and half those middle-aged men are on statins that lowers their cholesterol production. I
mm,
don't think that's a coincidence.
mm. Yeah,
So
so
we
precursor.
need cholesterol for lots of different things. And again, aiming all of our heart prevention efforts, spending all our health capital, if you will, on lowering an incorrectly measured molecule that actually, in its best sense, is vital to your health, and trying to lower this and measuring it wrong, and to add insult to injury, you're not even measuring it correctly. This is just the wrong target for heart disease prevention. We can do better.
And it's amazing how this still happens even after, I believe, was it in 2016 that the American Heart Association officially took it off the nutrient concern list?
It was just a few years ago. Yeah. Now, here's another place it gets more it gets more confusing. They took it off the list of nutrients of which we need to worry about. Nutrient meaning something you eat. There has been massive confusion for the last 60 years over eating cholesterol and cholesterol in the blood. Let us make them separate for a moment. The cholesterol you eat, such as in egg yolks or shrimp, except for a 0.00001% of the population that has a particular genetic condition. So, for all intents and purposes, for 99% of the population, the cholesterol that you eat has nothing to do with the cholesterol in your blood. 80% of the cholesterol in your body is made in the body. It doesn't come from food. If you eat less of it, your body makes more of it. If you eat more of it, your body makes less of it, because we need it, and the body will keep up with the need by making it. So eating less cholesterol doesn't even move the needle on blood cholesterol. And the irony is, we always knew that. Even the people who invented the theory of saturated fat and cholesterol cause heart disease, they knew they weren't talking about eating cholesterol. And they actually thought, you know what? It's too confusing for the public. Let's just say cholesterol is bad in general. It's too confusing for them to understand that you can eat cholesterol, but you can't have cholesterol in your bloodstream. Too confusing. We're just going to say cholesterol is bad. So let's get really clear that eating cholesterol, no matter how you look at it, does not harm you in any way. It doesn't raise your blood cholesterol, even measured by the old format.
Big mess, big mess. And I think what contributed to all this being a greater mess is, and it's, I don't like to go into it too much, but I think it's important to mention that there even was a powerful expose published in JAMA Internal Medicine, by the researchers of University of California. It dug up the old sugar industry documents and revealed that payments
Oh, I
from
love
the sugar industry to scientists to, say that the role of sugar, that to you know
to
blame
downplay the
sugar
role of
for heart
sugar and
disease,
upplay the role of fat. Yeah.
minimize, yeah. So that's, important to mention, and they it showed that the Sugar Research Foundation, now known as Sugar Association, paid Harvard scientists to publish manipulated reviews on sugar, fat, and their connection to heart disease.
I discuss this at length, and I give the references for it, including that journal article that you mentioned, both in The Great Cholesterol Myth and in our previous book, Living Low Carb, which talks about that entire period, and in which the sugar industry did, in fact, pay researchers to kind of look favorably on the theory that what was making us fat, sick, depressed, and tired, and overweight, and heart disease prone, and all the rest of it was fat, not sugar, and to just kind of shift the interest of research to fat rather than sugar. And that is absolutely true. And I documented in both books, and you're absolutely right. That was published in a journal article. It's also been published in wonderful books about this period by Nina Teichlok, who wrote The Big Fat Surprise, and Gary Taubes, and all of these people have written about that extensively, not just us. So you're absolutely right about that. And it's certainly something to bear in mind.
Yeah, beautiful. And these flawed studies continue. It's stuff like, again, Coca-Cola, providing $1 million of research and funding researchers to play
Yep.
down the link between sugar and obesity, and blames it on exercise.
Yep.
So
That's right.
this continues with these industries.
You are
Okay,
right.
so all right. So testing is important, just to know that there's so much more to it. Um, Cholesterol is essential for life. Fat is essential for life. In
Mhm.
Ayurveda, we have the fat tissue. We call it metadhatu. It protects us. And Dr. Johnny mentioned, but I want to emphasize the importance of brain. The fat for the brain, cholesterol for the brain. Most of our brain, not most, but a lot of it is DHA, right? It's it's important for energy production, hormones. We have fat in every cell. Um, so yes, perhaps. I mean, what about? There's so many more studies. Then there's studies showing that cholesterol, and it's interesting because I've read they're showing the studies are linking saturated fats with cardiovascular issues, and showing that actually there's no increased risk,
Right.
or even in fact people with high saturated fat, it
Right.
helps the cardiovascular, and obviously they weren't using cholesterol blood tests, right? The common blood tests,
Right.
because that would just not make that study very valid.
Right.
Stuff like Dr. Frank who did like nearly 350,000 subjects and measured the
Yeah,
difference about.
I'm glad you brought that up. You said Frank Hugh. I know that name is probably not familiar to the audience, but he's part of a very prestigious group at Harvard who have done a ton of studies like this. But here's what I want to point out about all these studies that link saturated fat with heart disease and uh, meat eating with prostate cancer. These are what we call observational studies. I think it is the basic point of scientific literacy. If we can get audiences to understand what an observational study is, we will do so well and realize how um, how they're done and what they really show us or don't show us. So, in a clinical study, you take two groups of people and you match them on every characteristic that you think could influence the results. So you want people of about the same age with the same basic medical history. You don't want, if you're trying to do a general study to see how something influences people, you don't want people in that study who have a terminal illness. You don't want people who have asthma. You want people who are basically generally about as equal as they can be. And, no two people are equal, but you certainly don't want a lot of people who are extreme on any scale. So you try to match them on their history, on if they're on medications or not, how active they are. If you want to study obese people, you want to make sure they're in a certain weight range. If you want to study normal weight, if you will call it that, people, you want to make sure they're all in that group. And you match these two groups. And then, as much as possible, for a period of time, you control what they do except for one thing, and that's the one thing you're testing. So, for example, if you want to test a pill on blood pressure, in an ideal clinical study, you'd have two groups living exactly the same way, in as much as possible, eating basically the same diet, doing basically the same thing, having basically the same measured levels of stress and all the rest, except one group would get the blood pressure medication and the other wouldn't. And then at the end of the 6 weeks or 6 months or whatever the study was, if the group taking the blood pressure medication had significantly lower blood pressure medication, you could kind of say, you know what, we think the blood pressure medication works. What else could it be? Everything else was the same. Now, you can do studies like that with animals because you can control everything from the temperature of the cage to the amount of calories that they eat. And then you can really see if one thing is different. That's hard to do with humans, but that's what a clinical study is, okay? Here's what an observational study is. You give out questionnaires to thousands of people and you ask them what they did. Do you understand the difference in rigidity and in rigorousness and scientific investigation? One is we're not telling you to do anything else. We're not putting you in any kind of clinical circumstances. We are not matching you into any kinds of groups. We're not doing any kind of treatment. We're not feeding you any kind of diet. We're just asking you what you did. How many hours did you sleep? What kind of food did you eat, if you even remember? How many days a week did you walk? And they get all of this data, and then they look and they go, well, it looks like the people who walked the most had the most holes in their shoes. Maybe walking causes holes in shoes. They're making guesses about what things go together. And these are the studies that Frank Hugh and Walter Willett and the Harvard epidemiologists and all these people do to kind of notice patterns of eating and outcomes. The problem with these studies is it's impossible to control all the other things that go with it. You see that people who eat meat also watch a lot of television. Oh, by the way, they don't eat much fiber. Oh, a lot of them smoke. Most of them actually do smoke. So scientists will try to control for that stuff, but they never get it right. There's always variables that you can't control for because all you're doing is observing people. It's like observing, wild animals in their habitat. It's interesting, and you kind of get some hunches about what causes what, but there's no science there. That's just an observation. And I like to, every year or so, I write an article in which I list some of the more humorous observational studies that have shown correlations, statistically solid correlations between, for example, the number of people with blue eyes who watched the movie Crash. There's more people with blue eyes, statistically more. There's a statistically, the one that I love because I learned it in Statistics 101 back in the 70s, is the consistent, statistically correlated relationship between the number of storks and the number of babies in Denmark every single year. That holds up. So is the conclusion that storks bring babies? And there's hundreds of these kinds of correlations that are either spurious or they're caused by some. In the case of storks and babies, if you're wondering why,
Stork, you mean like one of those birds?
what?
By stork, do you mean one of those
Yeah,
birds?
birds that everybody that when you're a kid you thought storks bring babies. Well, there is
Uh-huh.
a correlation between the storks and babies in
Uh-huh.
Denmark. That's a correlation. That's an observational study. So people would observe, yeah, whenever there's lots of babies, there's lots of storks, the same kind of places that happens. I wonder if the storks are bringing babies. Well, you don't wonder that because it's so absurd. But that's the kind of study that they use to say saturated fat causes heart disease. They observe things. If anyone's wondering how could the stork baby correlation exist, this is how it exists. In Denmark, in these areas, singles live in the city. Unmarried people live in the cities. They tend to flock to the cities. That's where all the jobs are and everything. And when people get married and they want to have babies, they move to the suburbs. That's kind of what happens in Denmark, right? In the architecture of Denmark, most of the suburbs have these sloping thatched rooftops. Guess where storks like to nest? Sloping thatched rooftops. So the storks go where the rooftops are, and the kids go to get married and have babies out where those rooftops are, and that's why there are more storks where there are babies. And this is what often happens in these dietary studies. People who eat more of this have more of that. Well, why? Is it really because of the food? We don't know unless we do a clinical study. When doing an observational study, it could be anything. And that's the problem with those studies. And that's why we need to stop basing our health policy on what somebody observed about how people say they ate and what they say the results are.
Hmm. Okay, before we go into statins, I just want to ask one more thing with the testing. What is your view on taking the triglycerides and dividing it by HDL to get a indication of whether the cholesterol is oxidized?
Well, as we write in the book, the triglyceride HDL ratio is probably one of the most important and telling and predicting metrics that we can possibly get. You can get it right off your blood test right now, even if your doctor never ordered another test. And the way you do that is you take your triglyceride number, which is 99% of the time going to be higher than your HDL. We'll talk about the rare and lucky cases when it's the reverse, but most of the time your triglycerides are, let's say, 100, your HDL is, let's say, 50. You do a ratio, which is the lower number into the higher number, and you get 2. Excellent. You're not getting a heart attack. Let's say your triglycerides are 150 and your HDL is 30, your ratio is 5, that's a risk. So that number not only is a good surrogate measure for risk for heart disease, but it's a wonderful surrogate measure for the condition I really want to talk about, because this is the one that really does predict heart disease. This is what we should be talking about rather than cholesterol. That ratio is a great surrogate for something called insulin resistance. And in our book, we don't do the research, but we find the research which has been hiding in plain sight since the 1970s that shows that insulin resistance shows up about 10 years before your doctor says, "Oh, Mrs. Jones, you got high cholesterol," or your diabetic doctor says, "Your A1C is really getting up there. Your fasting glucose kind of high. We better start thinking about some metformin or one of those drugs because we don't want you to be diabetic." 10 years before that happens, insulin resistance can be checked and seen. And insulin resistance can be treated, reversed, or prevented with diet. That's what we need to be looking at. And let me, Dylan, if I may, underline the importance of that. We're in a, I don't know how it's affecting your country right now. I'm in California. We're in total lockdown. We're recording this during the pandemic. And this is the connection to what we're saying to the pandemic. Every comorbidity for COVID, every pre-existing condition for COVID, all the ones that make you vulnerable, all the ones that make you immunocompromised. What are they? Pre-diabetes, metabolic syndrome, diabetes, obesity, high blood pressure, heart disease. Every one of them is statistically related to insulin resistance. If you could wipe out insulin resistance, you would probably prevent something like 42% of heart attacks worldwide.
Hmm.
That's what
Yeah.
we need to be doing. We need to make those dietary changes now, because I would argue, and again, we're hypothesizing here. We're in the middle of a pandemic that started less than a year ago. Nobody really knows. We don't have the benefit of 10 years of hindsight. But my guess is that the number of deaths from COVID would be significantly reduced if people weren't metabolically broken with insulin resistance, which is the most common metabolic disease in the world. And in our book, we show research that shows 52% of the world has some degree of insulin resistance. My friend Nina Teiclo, who wrote The Big Fat Surprise, great book, says that it's up to 88% in America. So insulin resistance is all over the place. People don't know they have it. Doctors don't measure it. We show you how to measure it in the book, and I'll tell you how now if you want. But the point is, it's there whether you know it or not. There are no symptoms for it. And the first symptom is when you go to your doctor and they say, "Hey, your A1C is really high. Hey, your fasting glucose is pretty bad. Hey, I don't like this cholesterol." That stuff is late. Those are late markers of metabolic problems.
So how do we measure it earlier?
And you can do it now with diet.
How can we measure it? You
Well,
said
there's
that.
four ways. Four ways, and there's a fantastic state of the art gold standard test that's given by a lab by LabCorp. But there's also a low tech way you can do at home right now without a bit of equipment and a bit of testing, and you can do it for free. And here's how you do it. And it's not 100% accurate, but it's so damn close, and you can't beat the price. Stand straight in front of a wall. Face the wall, a few inches from the wall. Start walking slowly towards the wall. If your belly hits the wall before your nose, 95% sure you've got insulin resistance.
Yeah, and this is important. This is why we had this conversation, because cardiovascular disease is, the biggest killer. But as you're saying, don't just look at the heart, like look at the insulin resistance, because that's like a crucial link. And then as Dr. Jonny mentioned, that 1/3 of Americans are pre-diabetic, but 90% of them don't even know it. So this is Metabolic health is so important, and we talk a lot about this in this podcast, in Jonny's book. So many doctors are now really addressing it, and diet plays a huge role, exercise, lifestyle, stress.
Let
So
me tell you about one piece of research we talk about in the book that not enough people know about. In fact, a
yeah,
very small number of people know about it. I hope the book will bring this research to more people's attention. So in the 70s, there was a doctor named Kraft who developed the test for insulin resistance. It was a state of the art test. It's even still used in some places now, the Kraft protocol, but it's very hard to give. You had to be in the doctor's office 3 or 4 hours. You had to really be willing volunteer. They hooked you up to two different intravenous uh, tubes, one of which would deliver a specific amount of glucose every hour, the other of which would deliver insulin. You could actually watch how insulin was able to clear blood sugar from the system, and you could measure how long it would take. So you really had a perfect test for insulin resistance. I'm not asking anybody to go get a test like that now. There's easier ways to do it. But that was the perfect test. And what he did 14,000 of these tests over the course of his career, and he put them into 20% quintiles. So the 20% that were the most insulin sensitive, their bodies just cleared the sugar right away. Insulin did its job. There was no resistance of the cells. They were good. Maybe 20% of the people were like that. The next 20% had a mild degree of insulin resistance, and the next a stronger degree up until the highest level of insulin resistance, right? And then he followed these 14,000 people for years and years, and he published all this stuff. He wanted to know what happened. So, in a 10-year follow up, there were virtually no deaths, no serious illnesses, no heart disease in the first 20%. And it went up from there. So the higher you went on the insulin resistance scale, the more likely you were to either die of heart disease or even some other diseases as well. And this was dramatically shown. Now, okay, that's one very impressive study. Then in the 80s, a guy named Gerald Raven from Stanford University comes along, and he discovers something called metabolic syndrome. And metabolic syndrome is basically a collection of conditions like high blood pressure, abdominal obesity, high triglycerides, low HDL. And basically, what underlies this metabolic syndrome is insulin resistance. And Raven showed clearly that insulin resistance is at the heart of diabetes. There is no question about that. But towards the end of his career, he wondered, like Kraft did, I wonder what else this thing's related to. So just for fun, he kind of replicated some of Kraft's research, and he said, "Okay, we know it causes it. We know that it's a direct causal element in the development of diabetes. What else is it related to?" And he did the same kind of division, same kind of testing, and he finds it's related to cancer, it's related to Alzheimer's, it's related to heart disease, it's related to all of them. And when I was making all those videos for YouTube about COVID and I was looking at all this stuff, I noticed that, gee, all the cardiometabolic diseases that are related to insulin resistance are on that list of COVID preconditions. And I kind of wondered myself about lung disease, liver disease, and kidney disease, which are also pre existing conditions that make it a really bad thing if you get COVID when you have that. And I didn't really know I thought, well, okay, insulin resistance related to five of them. That's enough. That's enough to make a case to change our diet. I spent a morning researching online at the National Institute of Health Medical Library, the NIH, the medical library, which is online at pubmed.org, um, pubmed.gov. And that publishes every clinical study that's ever been published. There's just thousands of pages of published studies. If it's been published, it's on PubMed. And I entered insulin resistance and lung disease, insulin resistance and kidney disease, and insulin resistance and liver disease. And guess what? A strong statistical correlation with all of them. So insulin resistance underlies every single disease that is a pre-morbidity, a comorbidity, pre-existing condition for bad outcomes with COVID. That's how important this is. That's how important it is that we turn our attention to reducing or preventing or turning around insulin resistance right now. Don't worry about cholesterol. That will follow. Do the important thing. Just turn around insulin resistance. And how do we do that? Let's talk about it.
Let's talk about it. And it's showing, COVID is just showing who out there is metabolically, metabolically ill, who's got the
And you know
chronic.
what, Dylan? We hear a lot about deaths that sort of fall outside the norm. A young, healthy baseball coach, 30 years old, a 41-year-old actor in New York, and they don't seem to have any pre-existing conditions and all of that. We don't know this, but if you look at insulin resistance and this kind of metabolic damage as an underlying condition, which it is, you have to realize that people aren't checking for it. They're not looking for it. They're not doing these tests. They're not including those as important metrics. And I honestly believe that if you really dug under the hood, you'd find that that metabolic condition underlies a lot of the deaths from COVID for people who you would think, well, I don't know, why would they die? They seem so healthy. You can seem very healthy and have underlying metabolic disease, as these statistics on insulin resistance show. So there's no time like now to actually take a look and see whether or not this is something you might want to reverse or at least um, stem the tide of. And you can do that by changing your diet.
Hmm. Okay, and before we talk more about what things you can do, I want to just go through the standard treatment, and that is statins. Let's talk about that because I believe it's the most prescribed medication. Is that right?
It's one of them, if not the. I mean, it
One,
changes, but certainly over
at
the
least in
last
the
10 years.
history of medicine, it's
Yeah,
potentially the most widely prescribed drug.
yeah.
So, they're disabling a critical step in the formation of cholesterol, which is affecting other, pathways and aspects of our biology. So, you can just let us know about statins and what they're actually doing.
Well, they do three things, but one of the thing that they're most famous for doing, the thing they do most successfully, is they lower LDL cholesterol. But as we just saw, that's not always the only target we should be focusing on. Statins have a lot of side effects. Don't let anyone tell you that if you that you're making that up, or that the pharmaceutical industry has done a lot of work to kind of group those people who talk about statin side effects as in the same group as the anti-vaxxers. I mean, they couldn't possibly have it. They're all crazy. It's not true at all. And doctors have that point of view. Doctors have the point of view that, oh yeah, there's a lot of bad publicity about statins, but the science shows that's not true. So let me tell you what the science shows. The science shows, and there's a great study which we talk about in the book and that we quote in the book by a professor at Stanford who actually looked at statin side effects. And what she looked at was how often doctors report them to the agencies to which you report adverse effects. Every government has agencies that handle adverse effect reporting on substances and poison control and all that stuff. And doctors are supposed to report adverse effects so that they can get adequate portraits of the profiles of these drugs so that they know like what's common, what's not common, what's showing up, what's not showing up. And what Beatrice Golem found was that 65% of doctors don't report statin side effects. And the reason that they don't report them is they don't believe their patients. And the reason they don't believe their patients is they have been so brilliantly marketed to by the statin manufacturers that they actually believe the patients are misattributing their side effects. So, for example, I play tennis um, with with people ranging from age 14 to 87. I'm not kidding. So I have a lot of people I play with in their late 60s and 70s. Most of them are on statins.
Mm.
And what happens is they go into their doctor and they go, doc, ever since you put me on Crestor, I have a lot of leg pain. Oh, no, Mr. Jones, you're just getting older. It's arthritis. It's not the statin. Doctor, ever since you put me on Lipitor, I'm having real memory problems. Mrs. Jones, don't worry. It's not the statin. It's a little mild cognitive impairment. It's normal at your age. That's what happens.
How
So
can
I
Patient.
want to be clear that we don't necessarily think statins are evil. We don't think there's a big conspiracy. What we are against is the overprescription of statins. What we are against is the giving out statins like they're candy, like they're a lollipop at the doctor's office, giving them out and advocating for them to be in the water supply because every doctor thinks they're such great things and they save so many lives, which is not true. What is important to know is that statins were tested in a certain population, middle aged men with previous heart disease. And they were shown to have a small and modest effect on middle aged men with previous heart attacks, in preventing a second heart attack. In other words, people who took statins had less likelihood of having a second heart attack. But then the statin manufacturers did the same greedy thing that every corporation in America does. They have a success and they do a brand extension. They want to figure out how can we get more people to buy our product. Well, obviously, middle-aged men with a heart attack, previous heart attack, is a limited population. What about men who haven't had a heart attack? Hey, what about women? Hey, what about not middle-aged? What about kids? And what about old people? They could all benefit from statins, and that's what they're doing now. And that's what makes our hair stand on end and our blood boil. There was a movement in America a few years ago where they were actually doing a big PR effort to get parents to take their kids into the doctor, get their cholesterol measured earlier. Remember, using this old-fashioned BS way of measuring it. Get their cholesterol measured because if it's up and you're 13 years old, we can prevent heart disease now. Let's put them on a statin now.
Oh,
Yes, and that's
crazy.
what's going on here in this country. And let me
Uh,
just remind you of something, remind the listeners of something you brought up earlier. Statins are needed for the development of the brain and for memory and for thinking. A kid's brain isn't even fully complete till he's 25. To give a kid a statin drug to prevent heart disease is medical malpractice. So
mm.
these statins are not innocuous drugs. They are not for everyone. I don't want to go so extreme as to say they are poison, they're bad for everyone. They're not. They do a couple of good things. They thin the blood slightly. They're mildly anti inflammatory, both of which you could do better with vitamin E, ginkgo, or fish oil. But they do some things. They do show some benefits. But lowering cholesterol is probably the least of the things they do that's any good. It's probably more important that they're mildly anti inflammatory. And they certainly don't have to be prescribed to the levels that they're being prescribed because we're measuring cholesterol wrong, number one, and we're giving this drug out, number two, as if it's candy and as if it would actually help everybody, when in fact that is not what the research shows.
So what I generally do for my patients on statins and most all Western medication, but whenever it's statins, it's I really see an opportunity for get them feeling better and overall health better. Then go back to their doctor and reduce it. Ask them
Yeah,
to
that's
reduce it.
very
The
good.
doctors,
Good idea.
So how can patients be, who want to get off the statins, who are on statins, kind of fast track that process, even considering that they have a doctor who is ingrained in this dogma, this outdated science. And
Well, I can tell you what I would do. I feel very strongly that to the extent that you can reverse, prevent, treat, turn back insulin resistance, all your blood metrics are going to improve. So I would actually concentrate on lowering insulin resistance. And how would I do that? Well, let's go back to what creates insulin resistance. Insulin resistance is basically your body's response to too many carbs. Now, people find that hard to hear because we've been indoctrinated to eat high carb diets. We've been indoctrinated to think that carbs are good because they don't have any fat in them, and low fat diets are good. So the less fat we eat and the more carbs we eat, the better it is. But the fact is that the human genus has been adapted to foods that we could hunt, fish, gather, or pluck. That's what we ate for the 110,000 years the Homo sapiens have been on the planet. McDonald's was a franchise in 1957. For most of those 110,000 years, we've eaten what we could hunt, fish, gather, or pluck. And that's not high carb processed food. So agriculture was invented, 10,000 years ago? That's like 5 minutes in the 24-hour time clock. We just aren't adapted to this amount of starch and sugar. And people who point out that, well, they eat plenty of carbs in Japan and they're not fat, are kind of missing the point. First of all, they eat way less calories. Second of all, they're way more genetically adapted to the rice that they eat. Third of all, it's not the same carbs. They're not. It's not even the same rice. And fourth of all, they're genetically different than we are. So there's just a million things that don't make those good comparisons. We are eating in America something like 3,000 calories or more a day, half of which or more come from carbohydrates. That's just more than the human body has ever been asked to be able to manage. And the body's reaction to that is insulin resistance. So what happens basically is you eat sugar, your blood sugar goes up, the pancreas releases insulin, and insulin kind of tries to act as a sherpa to get that sugar out of the bloodstream where it can do a lot of damage and get it into the muscle cells where it can be used for energy. And that works fine if somebody actually needs the muscle cells to be performing and pumping and doing activity. But what happens in modern society is that we eat all this sugar, more than we've ever been acclimated to before. And our muscles don't even need it because we're not active. So after a while, we keep eating this sugar. Insulin keeps trying to round it up and get it into the muscle cells, but they become resistant. They say, we don't need any. What are we going to use it for? He's going to sit in front of the TV all night. So when the cells start closing their doors, now you've got high blood sugar and high insulin. Now you've got the conditions for inflammation. Now you've got the conditions where cholesterol can get damaged. So you've got an entire cascade that really starts with eating too many carbohydrates. And when and what raises blood sugar the most is carbohydrates. Protein does raise blood sugar, but not nearly as much as carbohydrates. And guess what doesn't even move the needle on blood sugar or insulin at all? Fat. So, what sense does it make to tell people to fight diabetes and heart disease by eating a low fat diet, a high carb diet, which is just going to drive the process further along the road? The answer is to reduce carbohydrates and to increase healthy fat.
Beautiful. And eat less. Like as a culture,
And
we are
eat
eating
less.
too
But it's
much.
easier to eat less when you're eating more fat because you're full.
Mm. We've got coffee shops in every corner. We've got food in our pantry. We're eating every hour, 45 minutes, quick snacks. Start intermittent fasting. And we're going to get into the fats. I want to like specifically which fats to eat. And I just want to add to dealing with your doctor. If your doctor if his practice or her practice is still based on the medical establishment's embarrassing, outdated theory that fats cause heart disease, or that confined to this specific test, then find a new doctor if they're so ingrained. That's kind of just what I've been telling you. I'm just like, okay, I can't work with this doctor. I suggest go seek a second opinion.
I will tell you this, Dylan. I have been one of the most encouraging things in my entire career has been the fact that people write to me sometimes and say, I gave your book to my doctor. And I won't
Yes.
say that it changes every one of their minds, but I can tell you that I've gotten more letters than I can count. And I am grateful for everyone from doctors who said, thank you for opening our eyes. We did not know this stuff. We did check into these references.
Mm.
Holy moly, you've changed my practice. Now, I would say I've probably gotten less than 100 letters like that in my life. That's not a lot of change, but it's very gratifying to know that there are some people who are open to this message, who will actually look under the hood, read the research, see where the trending is, and go, oh, I think we ought to get off this old pathway. It's not going where we want it. And I think there's some new information that we want to act on. And we're seeing this kind of thing unfold with COVID. It happens all the time in nutrition and health. Some things that the CDC thought were very dangerous at first, touching surfaces. We find as science develops, we go, oh, you know what? We were wrong about the surfaces. That doesn't mean scientists are crazy. It means that they're looking at new information. And new
Mm.
information means sometimes that the things we tell people to do will change. Something we thought was dangerous turns out to not be so dangerous. Drinking coffee turns out to not necessarily always raise blood pressure. For some people, it's a very healthy thing to do. For others, maybe not so much. When that's because we've discovered genes that have to do with how we process coffee that we didn't know about when we were having those debates about whether it's good or bad. So science changes, and people are still people, whether they're doctors or not. They get stubborn. They get set in the old ways. They are subject to something psychologists call confirmation bias, which is where you only basically listen to, pay attention to, or hear information that supports what you already believe. We're seeing that in politics a lot. So you can't blame all these people for like being kind of recalcitrant when it comes to changing. But That doesn't mean the new information isn't something we should change towards. It is very important. It's illuminating how we're looking at diet. It's changing some of the demonized notions we have about fat and cholesterol, and we should move in that direction. We just have to be a little patient with the people who are kind of lagging behind a bit.
Yeah, yeah, and we're definitely seeing that a lot with COVID. That changing. Oh, actually, lockdowns are not effective, or and then recently, like the other day, maybe December 21st, 2020, or something like that. Actually, the PCR test is not so good. So it just keeps going back and back.
Yeah, but you have to understand, and it always pains me when I hear people just conclude from that scientists don't know what they're talking about and they're all full of it. No, this is like trying to fix an airplane while it's flying. I mean,
Yeah,
the data is just coming in. This stuff's less than a year old. We don't
yeah,
have decades of data about it. So of course it's changing, but understand that the same thing happens in nutrition and health. New
yeah,
data comes in. We didn't know
yeah,
how to measure 13 different kinds of cholesterol in 1963. Just like we
yeah,
didn't know how to text on a smartphone in 1980, so we used the flip phone in 1990. Things change, and this is about doctors and prescribers and the entire health edifice in whatever country you're in, kind of adapting to new information and new ways of treating things, and understanding that it's a little bit more complicated than we thought it was in 1963. But the good news is there's so many things we can do to improve our diet, to change our risk factors, and to influence the outcome. And we should be availing ourselves of those things instead of being myopically focused on a lab value for cholesterol that we're still using an outdated lab for.
Hmm. Okay, beautiful. And it's so great to hear doctors with open minds, like you mentioned. I mean, that is the best, most fulfilling when you do get a doctor reading your book and being like, wow, and then they're shifting. So that's really nice to hear. So I'd love to go into fats. Of course, there's so many aspects. And just before we do that, I want to just reiterate what you said. It's a very key concept in Ayurveda, and that is called okasatmya, which means eat what you are accustomed to. So Asians who are brought up eating so much rice or soy, I haven't been brought up eating soy. It may irritate my hormones and my thyroid, but for them, they've been brought up and their ancestors have been eating soy and soy, they're accustomed to that. That's relevant for them. And like Dr. Jonny mentioned, eating whole foods, like what ancestors did, not avoiding the packaged stuff, the processed things. So many things. Eating less, perhaps try intermittent fasting. Just 3 meals. Start with 3 meals a day, no snacks. Not snacking so often, regularly. Moving the body to use that, to burn that glucose, use that
Yeah.
energy. So it doesn't. So many things we talk about, but let's go specifically into fats and oils and for diet. What fats to eat. Of course, it's a huge topic as well because you have the saturated fats, unsaturated fats. The PUFAs. So many aspects, but people get confused and just don't know what fats to eat.
Yeah. Well, I wrote a book previously called Smart Fat, in which and I'll give you the 10-second summary of Smart Fat right now.
That's an impressive skill to get to give a 10-second summary of the book.
Is good fat and bad fat, and those categories do not break down in terms of saturated versus unsaturated, animal versus vegetable. There are good saturated fats and there are bad. And there are certainly bad unsaturated fats and there are good. So we need to stop thinking in terms of good and bad being equivalent to animal versus vegetable. I talk about good fat all the time and people go, oh, I know what you mean. You mean vegetable oil. Oh, you mean, oh, bad fat? Oh, you mean saturated or animal fat? No, I don't mean that at all. Bad fat is toxic fat. Good fat is clean fat. End of story. And they can be in either category. So let me give you an example of an animal product with saturated fat that can be good or bad. Factory farmed meat is cattle that is raised under the most horrific conditions you can imagine. They might as well be raised in a factory, they just happen to be breathing. They are treated horrifically. They are raised in cages. They are raised close to one another, so they have to be fed massive amounts of antibiotics to prevent them from getting sick. They are fed grain, which is not their natural diet because that fattens them up very quickly and makes them ready for market faster. Grain is not their natural diet. That makes their stomachs acid, so they need to be given even more medicines.
Mm.
Meanwhile, in order to get fatter, they're given bovine growth hormone, which makes them even more ready for market. So these miserable, horrible creatures that have been treated so miserably and so inhumanely for those of you who care about animals, but also so unhealthily for those of you who care about the end result in your health, you are now eating in the fat of those animals the antibiotics, the steroids, the bovine growth hormone, the pesticides that's on the grain that they shouldn't be eating in the first place, the medicine that was given to them for their acid stomach that they got from eating the wrong food. So that's factory farmed meat. And that, if that were the only meat that were available to me, I would become a vegan. And I'm very far from being a vegan. So let's be very clear that yes, the fat from factory farmed meat is a toxic waste dump. Now let's look at the fat from humanely pasture fed and pasture raised animals. No antibiotics, no steroids, no bovine growth hormone. And guess what? Because they're raised on pasture, eating the normal diet, they're kind of chewing on on curds and grass and worms and insects. So guess what? They got a lot of omega-3s in their fat. And guess what else they have? Something called conjugated linolenic acid, which is a fat that actually has some anti-cancer properties, and it only comes in the fat of ruminants that were raised on pasture. So here we have fat from an animal, and in one form it is a toxic waste dump, and in another it is a health food. Let's look at vegetable oils. The vegetable oils that were told to us to be so much healthier than the saturated fats. So vegetable oils are very high in something called omega-6. That's an essential fat, but it's pro-inflammatory. And when we got rid of the lard and all the other saturated fats that we were frying in, because these people told us, hey, vegetable oil is so much better. So restaurants now take these unsaturated fats, which are much more prone to oxidation at high heat, and they use them for frying. Then they cool them off at night, and then they heat them up the next day, and they use them again. And in the fast food restaurants, usually the oil lasts about 7 days. So you have 7 days of heating, unheating, frying, heating them up. By the time the middle of the week comes, that's a toxic waste dump of carcinogens, trans fats, heterocyclic amines, every kind of poisonous trans fatty acid and carcinogen you can imagine is in that toxic waste dump of food of fat. And guess what? It started it as a vegetable oil. So that's a toxic fat that's unsaturated. And I just gave you plenty of examples of saturated fats, which are perfectly healthy. So we need to look at whether fat is inflammatory and toxic or whether it's healthy. And it doesn't matter if it's saturated or unsaturated or animal or vegetable. There's a vegetable oil, there's a plant-based oil, palm oil, Malaysian palm oil. It's wonderful. It's red because it's got tocotrienols and carotenoids and all these good things in it. There's coconut oil. There's a plant-based saturated fat. Mostly those fats are medium chain triglycerides or a different form of fat. The point is, it doesn't matter whether it's saturated or not. It matters whether it's toxic or not. That's all you need to worry about when you talk about fats. And some of the fats that are least likely to be toxic are the nut oils, the unprocessed oils, the ones that are cold pressed. Olive oil is a great one. Avocado oil is a great one. Macadamia nut oil is a great one. As I said, Malaysian palm oil is a great one. Butter from grass fed animals. Ghee, the Ayurvedic food, which is just clarified butter. These are all great fats, and there's no reason to limit them. There's all the reason to limit toxic fats.
And toxic fats are probably the number one worst thing you can eat in the modern diet. I mean, people, if they're more health, are blaming it on sugar. They say processed sugar is so bad. Oh, I'm going to be sugar free. Sugar will stay in your body for, I don't know, a few hours, give you a bit of an insulin spike. But these fats, when they're rancid, these toxic fats that we're talking about, they become rancid. They just bleach, boil them and deodorize them. They deodorize them because they smell so bad after this extensive processing method, and they just congest the liver. And I think they can be in the body for like over a year, right? Potentially years.
Yeah, and we store our toxins in the fat, and that's why factory farmed animals are so toxic because all that fat stores all those compounds I just told you about that are so bad for you.
Mm.
Uh, so yeah, there's nothing to fear from healthy fat and from clean protein, um, and from fibrous leafy green carbohydrates, but there's a lot to fear from starch, sugar, processed carbs, cereals, breads, pastas, and all the rest of these kind of empty nutrient, high carbohydrate, high processed foods, and these high inflammatory omega 6 vegetable oils. Those two things, the sugar and the vegetable oils, are probably two of the worst offenders in our diet, and they are probably the biggest contributors to all the metabolic diseases, including heart disease.
Okay, and I've asked my audience on Instagram because I generally, before a podcast, ask if you have questions for Dr. Johnny, and I have some questions about how much ghee can I eat, how much good fats can I eat, and I'll give what I think first. I think it's just everyone's different according to your digestive strength and what you're used to. If someone hasn't eaten ghee before, then maybe they'll start with a little amount, but me, I can have tablespoons and tablespoons in my meal. So yeah, how much, and then also let's consider those who don't have a gallbladder as a separate thing.
I'm really at this point in my career, I'm 30 years in. I just am profoundly uncomfortable with giving recommendations in terms of percentage of calories. Like, you should 30% should be fat and 40% should be this,
Mm.
or giving caloric recommendations, or even giving amounts. And the reason for that is, after doing 10 to 15 years of private counseling and coaching and personal training and nutrition counseling, and then another 15 years of teaching and lectures and Facebook lives and blogs and television shows and all of this, I have found that nobody follows those kind of recommendations. Nobody goes around with a meter calculating the number of calories, trying to figure out the percentage on a given plate of carbs and protein. It's just, it is a no-win strategy that just never works. So I am much more comfortable giving ranges of amounts that will
Mm.
work for different people depending on the circumstances. I've seen diets as high as 80% fat work great for some people. And I've seen diets as high as 80% carbs work. Now, I give you a caveat about that. I mentioned this in the book Living Low Carb, when I talk about exactly what we're talking about now, why different diets work for different people, and you got to kind of look under the hood to figure out what the right match is. The Bantu, our tribe in South Africa, in Africa, that eat 80% of a carbohydrates for their diet. They are lean, they are healthy, they have no heart disease. So how is this possible if carbs are so bad? Well, you wouldn't recognize any of the carbohydrates that they eat. They're bitter, they're tubers, they're wild blueberries, they're bitter little fruits that they pick up. They're tubers, they eat about 100 grams of fiber a day. So depending on what the food is, and depending on what the people are, their genetic makeup, what they're used to, what you say, what's found nearby. You mentioned something about that earlier.
They're
All of
accustomed to.
these
Yeah.
influence how well a person adapts to any particular diet. And in that context, I have seen a wide range of different combinations work. If somebody is specifically on a keto diet, it's going to have to be mostly fat with
Mm.
a moderate amount of protein and very low amount of carbohydrates. But I think a lot of benefits can be gotten from flirting with ketosis. I don't know that you necessarily have to be in ketosis all the time. I like I believe in the kind of heavy rotation view of diet, that you have like basically couple dozen foods, maybe a dozen foods, that you just kind of rotate around like a radio station that plays the top hits, and people will go off that list from time to time and have some other things. But basically, if you've got a lot of nuts, berries, olive oil, um, wild salmon, grass fed beef, olives, uh, some beans, maybe for people who tolerate them. If those are the basic foods that you eat, any vegetable you can think of, um, I think the proportions and how you mix and match with that everyone is going to kind of find the solution for themselves, and figure out what they feel the most energetic on, what they feel the best on. Some of the health hackers in your audience might start using some equipment like continuous glucose monitors to measure what the blood sugar effect of food is on them. But most people can just tell by how they feel. If you feel brain foggy, you probably had too much of something that you shouldn't have had. And if we're willing to kind of play with those proportions, and you start with that basic menu of 12 or 13 things that are all good for you, and you just rotate them, then I don't think we need to worry so much about the amount of each thing. I think the best nutritional advice I ever gave and the best nutritional advice I ever got in my life was three words: eat real food. If you start with that premise, all the rest is details. How much fat, how much protein, how much carbohydrates. Is it a real food or is it not a real food? Is it toxic? Is it processed or is it not? Those are the things to look for. That's the take home from this. And if you start there, you got a really great place and a great foundation to
I
build your.
agree. It's not the best question, and yeah, it's so dynamic. But see how you feel. Eat the good fats, and you'll be fine. Do the experiment. Don't go to extremes.
Yeah.
And can you address those who don't have a gallbladder? Should they be restricting fats?
I think that's a profession, a question for their individual health practitioner because people have different responses to that. There's a wide range of opinions about that. You certainly don't have to eliminate fat, but there may be you may want to do a little bit more testing and a little bit more checking individually to see how your body processes different things. There are some genes like the ApoE2 gene, for example, that do very much influence how people are able to process fat, and some people who have that gene perhaps have to reduce their fat a little bit. So there's a million ifs, ands, or buts to this stuff I'm talking about, and I don't mean it to be a prescription for everyone. I don't believe in one size fitting all for everyone,
Mm,
in anything, but I'm talking in general, and I always want to emphasize the fact that if you have a specific situation like the lack of a gallbladder or something like that, that you do probably want to follow up with a health professional, not get general advice over the internet, or even from interviews like this, and you want somebody to actually look at you
mm.
and see how you do with different amounts of food or fat.
Okay, beautiful. Okay, we've covered a lot. I really thank you, and I hope you listening really, can go beyond this dogma in science.
And I
Looking,
hope there's a demand in Australia for my book, The Great Cholesterol Myth, because I know I've been interviewed on a lot of you guys. I'm so thrilled whenever I hear it's from Australia because there seems to be such an awareness of health, at least in some population there. And so, there must be some large section swath of the population that really does care about this stuff because you guys have audiences and the podcasts are so intelligent and well, the questions are so good. So I hope that my book's available, and I hope you guys will read it and give it to your doctors and create some kind of demand for a reevaluation of this whole ancient way of looking at heart disease and cholesterol.
that's beautiful. Yep. So, for Dr. Johnny's book, the Great Myth of Cholesterol, or the Great Cholesterol Myth, you can get on your regular book sites, Amazon,
I'm sure.
and if you want to follow him on Instagram, it's Johnny Bowden. And what's the best place for people to find you and find
Instagram
your
is
work?
great. Twitter at Jonny Bowden, and I have a website as well. Just remember, Johnny is spelled with Jonny, no H.
Okay. Yes. All right. Thanks so much, Johnny.
Thank you, Dylan. It was a pleasure to be with you, and thanks for having me.
Thank you. I love your passion.
Thank you, man. Bye bye.